Thank you. Robert, thank you very much. Now, they'll be heading over to the AMA corner, so if you want to ask your deeper question or anyone else has some questions for Jeff and Robert there, please follow them out now to the AMA corner. Now, next we have Mike Goelzer. He's going to be talking about Libp2p. He's from Protocol Labs, and he has a great title, Leader of Product Management for Libp2p, but I'm particularly impressed by Mike's background. He's not only an entrepreneur engineer, but he's also been a computational chemist. But yeah, also worked a lot on Docker. Please welcome on stage Mike Goelzer. Thank you very much.
Thank you. Okay, hello everyone. Thank you all for coming out to the Libp2p talk. There's been so much interest in Libp2p in the past few days, and I'm really quite excited about that. So what I found is that there's like a broad spectrum. There's people who probably came here because they've never heard of Libp2p and are curious what it is. And then at the other end of the spectrum, I've got folks who are coming up to me, like pointing to specific lines of code in their projects using Libp2p and asking me, you know, why doesn't this work? And so what I've decided to try to do is this is going to be like a play in 2 acts. This talk, which is the next 30 minutes or so, is going to be a relatively high-level introduction to Libp2p. And it'll be, for those of you who have never heard of it, I think it'll be very helpful. For those of you who are very advanced and already know a lot about it, I think you'll find it interesting, but perhaps not fully satisfying. So what I'm then going to do is immediately after this, I've booked an hour and 15 minutes in the pop-up node, which is just it's in the hackerspace. It's where the meetups have been. And anyone can just come out. You can ask your question. No question is too basic. No question is too advanced. It's just like we'll talk about whatever folks in the group want to talk about. So that's kind of the plan for today, and hopefully that'll kind of make everyone happy. And so that's where I'm going to go. What I've done is structured this talk into basically 4 parts. Thank you. I would have needed that soon. What I've done is structure this talk into 4 parts. Basically, what I want to cover is the why, then the what, then the how, and then a demo if there's time for it. So first, I'm going to start out, and I'm going to jump into why did we build Libp2p. So Libp2p, in one sense, it's a peer-to-peer, it's a modular peer-to-peer networking stack that you can use in your own dApps or anything that needs peer-to-peer. It's not tied to blockchains. It's not specific to any specific application. It's just a set of modules for peer-to-peer. And the why we built it is just to kind of, as a reminder, and I think a lot of people in this room would know this, but the predecessor to the internet was something called ARPANET. And ARPANET was developed during the Cold War. And a lot of the thinking that drove the design of ARPANET was, what would you do if there was a catastrophic failure, like a global war, and it took out all of the telephone companies' switching offices, which, you know, they're in places like New York, Los Angeles, and let's say these things are completely destroyed. How would you build a network that's so resilient that it could just dynamically readjust itself and be able to continue functioning in the face of this catastrophic scenario? And so the answer that academics and engineers came up with was basically to have a highly decentralized network, don't have a single Bell telephone company switching office, have every node on the network be its own sort of switching office, if you will. And so that's sort of the motivation for a lot of the original design of the internet, this desire for decentralization. But if you look at where we are today, we have these services that many of us know and love and use every day, but they largely follow a centralized model, which is not conceptually dissimilar to what was what was being done by the phone company in the 1950s and 60s. They have centralized servers. Most of these are in data centers. Data centers tend to be on the outskirts of major cities, so it's basically similar sort of problems, but a nicer user experience perhaps than a long-distance phone call. So this was a big part of our thinking, is we need to bring the internet back to its roots. And as we started looking at decentralization, we looked at other problems that exist in the current internet that we thought we could solve through a renewed focus on decentralization. So I have some examples up here. Firewalling is a good example. Things like NAT, the fact that devices don't have IPs that are necessarily publicly reachable, which makes peer-to-peer extremely difficult. There's the problem of high latency networks and offline applications. A lot of people want to be able to use browser-based applications, but with intermittent connectivity, on trains, in rural areas, things like this. A few other problems is roaming. So this is the mobile addressing problem. Like if your cell phone is connected to the Wi-Fi and you walk out to the street, your IP is going to switch over to some Deutsche Telekom IP, and your device has not changed. It has the same identity that it did before, but all of a sudden it looks completely different. And so how do you have persistent identities for devices? For peers across these networks. Runtimes have proliferated, like devices have proliferated in general. It used to be, as recently as like 15 years ago, everybody wanted to program just for desktop PCs. Now you've got like mobile phones, Raspberry Pis, like just all kinds of devices that were never envisioned before. And we'd like to create libraries that let programmers write code once and then are able to deploy against many different types of devices. And the last thing I'll say is innovation in networking protocols is extremely, extremely slow. It is very conservative by design because you don't want to make a haphazard change to some protocol and then break the entire internet. But at the same time, it's very difficult to deal with that. So there is some prior art in peer-to-peer that many of you will be familiar with. This is one that people aren't as familiar with, but Skype was originally designed as a completely peer-to-peer system. They had a concept of super nodes, which were like relay nodes, but it was before Microsoft bought it. It was fundamentally, it was completely peer-to-peer. Traffic could be routed through your neighbor. The other ones you probably know of, they're mostly focused on file sharing. This is like the last generation of peer-to-peer applications. Libp2p is different from these in a few key ways. First off, what we're trying to build is not an end-user application or closed source sort of product. What we're trying to build is really a reusable library of building blocks that other developers can use. A second big thing is we're not focused on the anonymous file sharing use case. Like from our perspective, if you want to exchange, TV shows or movies or whatever, like that's a solved problem. BitTorrent is very effective for that. We're not trying to get into that area. What we're trying to do is really power the communications layer for the next generation of dApps and leave kind of these older use cases to technologies that already exist. We're also very focused on multiple devices, interoperability between different devices, and we're completely focused on open source. Everything we do is either MIT licensed or dual licensed. Yeah. So now I want to get into the what a little bit. Basically, Libp2p is a set of modular building blocks, and these building blocks are you can pick out which ones you need for your application, and each of these building blocks has a well-defined interface. It has documentation. It has a clear explanation. I think I go through a bunch of screenshots here, but it has a clear explanation of how do you use it, what do you use it for, what is its purpose. This is from the JavaScript documentation. I'll show a little bit more later. And then the idea is that all of these building blocks, which are independently usable, come together as sort of, these are collectively Libp2p. Just because this is a relatively technical audience, I want to spend a little time explaining what I mean by some of these building blocks. So we have a stack that's both opinionated and flexible. It's flexible in the sense that you can pull in the things you need and ignore the things you don't. It's opinionated in the sense that the way that we've implemented things, you have to buy into some of our abstractions. So what is a transport? This is a concept, an abstraction we created that abstracts away the question of how do you exchange data between 2 points. And the most common transport is TCP. It's the most commonly used one. But we also have other transports. We have a Tor transport if you want to route all traffic over Tor. We're working on Bluetooth and Wi-Fi transports for like my phone to your phone, short-range device-to-device communication. We've even talked about ultrasonic transports. So some of these can get a little interesting. Stream multiplexing is, obviously this is a concept that I think is familiar to most developers, but we have abstractions for having multiple streams running on over a single connection, regardless of what the transport is, because that's a lower level concept. Crypto, this is probably something that's better addressed in the meetup that I'm going to do afterwards. It's a little more detailed, but basically we're in the process of switching over to TLS 1.3, which has good support for peer-to-peer. Previous versions of TLS required you to have some concept of one party is the client and one is the server. That doesn't really work in peer-to-peer. 1.3 is the first that kind of doesn't have this requirement. But either way, we provide crypto, encrypted connections with sane defaults. Content routing and so generally, once people have a peer-to-peer network up, they want to exchange data somehow. The data could be files, it could be streams, it could be whatever. But so we have building blocks for content routing. Record stores, we have a distributed hash table built into the library. I'll probably try to go into this in more detail afterwards. But so we let you store records in the distributed hash table, and that's what is meant there by record stores. Peer discovery is also something we do through the DHT. So discovering what other peers are out there. NAT traversal is a huge topic. I can barely scratch the surface of it in the amount of time I have left. But in general, we're trying to pursue a few different strategies so that you can have two natted peers and they can communicate either intermediated through a relay peer, or there's various tricks you can do at the TCP level. There's something called TCP dual open, where it's actually in the TCP spec. If two machines simultaneously reach out to each other and send SYN packets, it triggers special behavior in TCP that will allow them to establish a connection, even if they don't have each other's IPs directly. And most routers actually support this because it's part of the spec. Peer routing, fairly obvious. This is related to routing information about the peer, what peers are in the network. A few things not on here. We have a publish-subscribe model, so even without going to all the trouble of setting up a DHT, you can set topics that you want to subscribe to, and other nodes can publish on those topics, and those messages will get routed around. And we have various implementations of that, ranging from very naive to gossip-based approaches, and we're thinking about more. So that would have been like 8 slides if I had kind of understood some of the technical depth that people wanted from this presentation. But again, I'm going to do an hour of this after for people who want more. A question we get a lot is how does Libp2p differ from the standard OSI model? Without dwelling on this too much, the OSI model itself is kind of obsolete. It's really, there are better models that describe how the modern internet works than the OSI 7-layer model. But if you've ever read a networking textbook, you've certainly been exposed to the OSI model. I'll just say that what our design philosophy is really about having building blocks that are defined by what they do rather than having a hierarchical stack. So, you know, our transports, for example, are covering multiple layers in the stack. They could be, one end of it could be down at the bottom layer at the Ethernet switch layer even, and then it could be communicating to nodes that are at much higher levels in the OSI model, but to us, it's just a transport. This is the kind of who part of the talk. So basically, we started out with IPFS, and we factored Libp2p out of it. If you're not familiar, IPFS is Protocol Labs project. It's called stands for Interplanetary File System, and the goal is to build, I don't have time to go into IPFS in this talk, but the goal is basically to build a file system that is peer-to-peer, that preserves content permanently and is good for archival and use cases like that. We factored out Libp2p, which is just the communications layer, and I'm going to skip that. No. That's a good slide, but I'm cognizant of the amount of time they've given me. We have implementations of Libp2p right now in 3 languages, JavaScript, Go, and Rust. And then we also have a variety of community-contributed language implementations that are at various stages of development. So some of these may be full language implementations. Some of them may be bindings around a Go daemon that just let you use Libp2p from Java, but without having to rewrite everything in Java. It really depends on what the community wants. We, meaning Protocol Labs, we're not trying to control what everyone can do. One significant consequence of having a JavaScript implementation that is basically relatively complete per the spec is that it runs in the browser. Running in the browser is great from a UX standpoint, but it's also really important because it gives us mobile, it lets Libp2p work in mobile environments too, which is not common for these types of low-level libraries where you tend to, most implementations want something like a kernel module, and that's not realistic on on some of these phone platforms that are kind of walled gardens. So in terms of who the community is, there's a very small number of full-time employees at Protocol Labs who work on this full-time. The majority of the contributions come from the community, and that's how we want to keep it. We want this to be a community-owned project. It's not, we don't really benefit if it's just PL working on this. We can achieve our own goals faster with just a project that we control. But we really want this to be a true community project, and so we're always trying to attract more people to it. I'll give you a few examples of some adopters. Ethereum. Ethereum is now kind of a sprawling entity with a lot of different moving parts to it. Within the Ethereum 1.0, there is some interest in adopting Libp2p as a substitute for dev-P2P. Within the Ethereum 2.0, which is sort of the sharding aspect of the next generation of Ethereum, there's also a lot of interest in Libp2p. Polkadot is another good example of a blockchain. That's this project from Parity. Substrate, which you heard about yesterday, incorporates Libp2p as a major part of its foundational layer. Let's go through some of these. So There are also applications that are being built on top of Libp2p. Some of these, you can look these up. They're collaborative editors. Live2p is a good example of a real-time video streaming system. It's so also based on Libp2p. OpenBazaar uses Libp2p a lot. They're kind of what eBay was to Web 1.0. OpenBazaar is trying to build for Web3. Then this is my usual join us pitch. Let me try to jump into a little bit about how do you use Libp2p. So as I mentioned, there are 3 language implementations, 3 officially supported language implementations, JavaScript, Go, and Rust. Each of them has its own set of examples and explanations. So whichever language you're most comfortable in, you might want to start with those examples. So here's kind of where you would go to find examples for each language. It's, as you can see, it's following a pretty standard format. It's just we have the GitHub org Libp2p, and then within that there's JS Libp2p, Go Libp2p, Rust Libp2p, and each of those just has an examples directory, and that's kind of the best place to see some sample code and some build instructions for how to use it. That URL at the bottom is our specs repo. The goal for Libp2p is really to be a specification first library. So we have strong implementations, but we're trying to make sure that in all cases we're implementing against a specification so that anyone else could come in and re-implement the same, the same thing in another language or in some other environment. So here was a quick demo I was going to do, and then whatever time is left, I am happy to take questions, and then after that, we'll take them to the meetup. This is a repo that you can go to. It's a public repo. It contains a couple of different interoperability demos between different languages. So in addition to those examples, example URLs I showed you earlier, so just /example in any repo. We also wanted to provide some examples of like how do I, what do I do if I want a Rust node to talk to like a Go and a JS node? How do I do that? So this one's nice. I don't know. I guess videos just autoplay here. So this is the README of the repo. The idea is that there's a couple of demos in there now. This is ultimately going to become workshop content. The first one was about distributed hash tables. You had already scrolled by. The second one is about PubSub. I just put this video in to show that like it's pretty extensively explained. Like what do you need to run to get this demo, to compile and then to use the demo, and then like what is actually happening in the demo, so that what does this prove? Again, I would love PRs on this. I'd love people to open issues. Everything in the project, like we need more feedback. We need folks who want to work on documentation. We need folks who want to build features. So we're always welcome to new contributors. So let's see. So the example I'm going to show you right now, and I'm not going to dive into the code, but you can clone it yourself if you're interested. But fundamentally, this is a PubSub example. It takes 3 peers in Go, JS, and Rust, and it initially connects them by connecting to a single Bootstrap peer. That's the blue box at the top. And then once they're connected, they all listen on the same PubSub topic. And they both listen and publish on the same PubSub topic. And so what you get is basically a chat example, a terminal chat example that shows the use of PubSub. Let's see. So here's the video. The top left terminal is the Bootstrapper node. I think first it shows the compile step to. I just want to make sure it's going to play. It first shows the compile step, which should start at some point. Sorry, I'm afraid I'm not. OK. OK. So the top left is the Bootstrap node. It's going to be the aggregation point for the other 3 terminal windows, which are just the Go, JS, and Rust. I don't want to call them clients, peers. So it's going to run with this -- bootstrapper flag. Again, you can check the code to understand more, but basically this is just a central point, a central rendezvous point for the next 3 of them. Then the top right window is going to be the Go node. It's actually the same binary, but just without that -- bootstrapper flag. This again is it's all explained in the README. It's going to connect. It's going to use its own private key. So peer IDs in our system, this is one of the ways that we're opinionated. Peer IDs are simply the public key portion of a public-private key pair, and we let you choose different key pairs. So now you're seeing the same connection sequence happening in JavaScript, bottom left, and Rust, bottom right. And you can see as each of these spins up, the Bootstrap node is just writing the standard out that, hey, I got a connection from this peer. And now I think I go into the part where I type a little message in each one. So here's hello from Go, and everybody else who's subscribing on the topic, which is all of them, they're going to see that message. And then you do the same hello from JS, hello from Rust, and everyone's going to get the same information. Honestly, this alone isn't that interesting, but the point I'm trying to drive home is that this is like one component that we're offering out of maybe not quite a dozen, but a little less than a dozen like major peer-to-peer building blocks. So if you just want a pub subsystem, if that's all your application needs, then you pull this out. And if you want a distributed hash table, which is a really common mechanism in peer-to-peer to discover other peers and also announce the location of content, and in some cases exchange messages, you can just pull that out. If you just want our crypto, which, as I said, we're going toward TLS 1.3, and we may also do an alternate crypto implementation using signals noise, so you'll have more than one option. But if you just want our crypto package, you can use that. Some of these have dependencies on each other, but for the most part, or I'd say it like this: some of these have dependencies on a small kernel of opinions that we sort of are our opinions about how to design this type of thing, and you kind of have to buy into them or not buy into them. But in general, they're very modular, they're very reusable, and I have about 50 seconds left on the clock, so I just want to repeat. This was meant to be a high-level overview. I hope it was useful to some people. If you want to get down into the details, come join me immediately after this in the hackerspace. It's called the pop-up node or the meetup node, and we can go into details. I've also, a bunch of the engineers are going to be on IRC, so if you have a really specific question, I'm happy to tackle that there. And in general, if you don't have time to come to that, but you still want to get involved or talk, best place to find us is #Libp2p on Freenode. We hang out there a lot, no matter what. And we also chat a lot on GitHub issues, like if you want to post a gist and ask for feedback on your code. So that's Libp2p, very briefly. Thank you.
Thanks, Mike. Do you want to stay here just for one question?
Oh, sure. All right, they've told me I can take one question. So, all right. Yes, sir.
Just wait until the microphone comes to you.
Yeah. What are the plans for interoperability with WebRTC? Do you have any plans to put some stuff? Yeah,
so we are working on WebRTC mostly in the JavaScript implementation. We're really interested in it because it provides a lot of capabilities that we can't otherwise do in the browser. I think that's I think a roadmap for that is probably a better question for the JavaScript team because it's sort of up in the air right now. We have other transports like Quick too, where I think we're sort of fleshing out like in what order to implement these. It's a great question. You should come out to the talk, and I have a couple of JavaScript engineers who are standing by to sort of address that. Yeah.
Cool.
Is that good?
Right. Well, yeah, so normally I'd say that Mike is walking over to the AMA corner, but as he's explained, he's not going over to the AMA corner. He'll be going straight into the hackerspace to the pop-up node. So if you do have more questions, and we saw lots of other hands go up at the end there, please follow him now through to the hackerspace and continue the conversation there. But everyone, please, let's round of applause for Mike.
Thanks.
Mike, thanks very much. Cheers.
Thank you.